Hello, and welcome to 5 Minute Math. Today we are looking at the fourth grade STAAR test from 2025. I'll be walking through the entire test using a modified version of the statewide item analysis report. If you would like to access that yourself, you can do so by using the tiny URL or the QR code you see on the screen. And if you want to jump ahead to any particular problem, you can do so by using these timestamps here, or you can use the bookmarks at the bottom of the video. For our first problem, we are looking at 4.8c. This is solving measurement problems. Specifically, in this case, we are measuring money, or we are using money to solve a problem. We've got two 20s, two 10s, three dimes, six pennies. We buy this, so how much left over do we have? Well, so what we need to do is we need to add this all together. So I've got two 20s, I've got two 10s, so I'm going to go ahead and add that up because then I've just got change after that. 20, 40, 50, 60. And then I've got three dimes, right? That's 30 cents. Six pennies, 6 cents. So put those together, 36 cents. So that's step one, making sure that we understand we've got $60.36, and now we are paying 36.89. How much money will we have left over? So we're just subtracting, we're finding the change. So that's going to be a 7. We do need to bring the decimal down, and we are going to need to subtract across this 0 here. So that's 5. That's going to be 10. Now we can take 1 away to get that extra 10 for the dimes. So we've got 4, we've got 3, we've got 2, 23, 47. Our answer here is A. And this was the beginning of the test, and it's fairly simple. We had 65% of our students get this one correct, and so that was pretty good. It's an easy one to start with. We had 15% of our students choose C, and as you can see, right, we are just $10 short, so maybe only added 110. That's one possibility, one $10 bill. Or we could have just made a mistake when we were regrouping or carrying or something like that. There's a few different ways to get there. Overall, this was a fairly simple problem for us to get started with. This was actually tied for our 7th easiest item on the test. And so that's typically what happens when we begin tests. Is they start out kind of easy, they crescendo in the middle, and they come back down towards the end. So let's get that right there. So for number 2, we are looking at representing data. This is 4.9a, and we are trying to move these numbers off of this dot plot into this table, and we don't need to overthink this. This is not that hard. So there's 1, that's 31, goes right there. How many do we have? 35. Here's my 35. Literally, we just need to put a 2 right there. So let's put a 2 right there. Now let's look at our 40. I've got 1, 2, 3, 4 right there. So let's move that 4 right there. And then I've got my 143, and it's just right there. Then I've got 4 on the 50. It's that last one I'm looking for, 47. 1, 2, 3, 4, 5. And so I just need 5 right there. Yeah, and this is basically as difficult as this problem is here. And so this was actually a 2-point problem. So you get 2 points if you get all 3 correct. So I'll put that right there, 3 correct. We had 80% of our students, 80%. That is extremely high, even for a multiple choice question. But in order to drag and drop this, that's really, really good. You get 1 point if you get 2 correct. So they might have miscounted 1 or had a misdrag. So that's a 7%. So if you put these together, you get half credit for the 1 point. That's 84%. This is actually our first easiest. This is the simplest problem on the test. Now, we had still 12% of our students get 0 points. This is either 0 or 1 correct. So it's not 100%. We still have some students just confused on this. Obviously, this 17 is just counting everything all up. They might not have been familiar with this, but that's probably because they have not interacted with a dot plot in a table. So going back and forth between those two is going to be very important. Number 3, we are looking at 4.4b, multiplying by 10 or 100. And so we've got 120 paper packs. Each pack has 100 sheets. So how many total sheets are there? Well, if we wanted to, we could multiply by this, but we don't really work on a 3 by 3 multiplication, and we don't have to. When we multiply anything by 10, we simply add 1 0. When we multiply anything by 100, we simply add 2 zeros. When you're multiplying by 10 or 100, you just add 1 or 2 zeros. So let's move those up here. That's just the pattern that emerges, right? And so we are going to get 12,000. And so our answer here is going to be D. And that's just a simple recognition problem there, but we only had 53% of our students get this correct. And we see that we're kind of evenly distributed amongst the distractors. Now, the fact that 220 is an answer choice that students still chose, and actually that's the highest distractor out there, that's simply 120 plus 100. And so we weren't necessarily noticing that we're dealing with each pack, which gives us equal groups, which means we are going to multiply or divide. And so that's quite a few students that missed that term there that signals that we have equal groups. But overall, this was right around the middle of the test. This was the 16th easiest item on the test, 32 items altogether, so this is right in the middle. For number 4, we are dealing with 4.7c, and this is, as you can tell, a multi-point problem because we are needing to select uh, two answers that do not have the measure of 70 degrees. So we're going to need to scroll, and we're going to need to do a little bit of calculation here because we're measuring angles. And so we're looking for those that do not. So let's not forget not here. And so if I'm looking from this right here, I'm looking on the outside, 0 all the way to 110. I know there's 70 right there, but look, that's a right angle. This is bigger than a right angle. This is obtuse. So 70 is not going to work because 70 is acute, right? And so this is actually going to be one of our answers because this is not 70. This is 110 degrees. All right, let's scroll down here and let's see what we've got. Now I'm looking on the inside from 0 and it goes up to 70. That looks good. So B is not it because we're looking for those that do not have 70. All right, let's keep looking. Now, I don't have anything on 0 here. So I'm going to use either inside or outside. I'll use inside here. From 10 up to 110. So 110 minus 10, that's going to be 100 degrees. Or I could do from 70 up to 170. So 170 minus 70, either way. 100 degrees, which means that's the one I don't want. So that's our answer, because it is not 70, which means the last two should be 70 degrees. Let's clear all that. These are our last two. So yeah, this goes from 0 all the way up to 70, so that's 70. And then this goes from, on the outside, 60 to 130, or on the inside, 50 to 120. Either one is going to get a 70. So these two, option 1 and option 3, if you want to call them A and C, that's fine. Overall, we did decently on this. We had 49% of our students get 2 points, which isn't great, but we actually had 37% of our students get 1 point. You put those two together, you're looking at 68% correct because you get half credit for that 1 point. And for 0 points, we had 13% of our students. So this was actually much easier than it might initially seem. This was actually the 6th easiest item on the test, right? And so we probably are able to just infer, even if we're not sure with protractors work, that 3 of these look the same, 2 of these do not look the same. So we can use some visual cues there as well. For number 5, we are looking at expanded notation. This is 4.2b, and this is your standard expanded notation problem that you might see, but we need to put it in word form rather than standard form. So let me put it in standard form first. So I've got 1 in the 100,000. So I'm going to go up to 100,000s, or thousands, excuse me. So I've got my thousands, my hundreds, my tens, my ones, and then let me get my decimal here, and then hundreds. All right, so I've got a 1 in the thousands place. I've got an 8 in the hundreds place. I've got a 4 in the tens place. I've got a, okay, 2 in the tenths place. So I'm skipping ones. I'm going to put a 0 there. I've got a 2, and then I've got a 9 in the hundredths. So then I just need to write this out. This is going to be 1,000, comma. They all have that. What is this right here? This is that period right there. And let's put a comma right there. 840. And so we'll check to see our answers here. 840, 804. That's incorrect. 840, 84. Okay, so I'm down to 2. And then I've got 29, and then you put that last place value there. 29 hundredths. 29 tenths? No. 29 hundredths. There we go. Our answer is C. And we had 70% of our students get that, which is really high. We should feel good about that. We had 15% get A. That's the most chosen distractor. And you see that they got all the way to the end and they just messed up the hundredths and the tenths. But overall, this was fairly easy. In fact, this was the 5th easiest item on the test. For number 6, we are classifying two-dimensional shapes. This is 4.6D. And we've got 2 different polygons. And as you can tell, this is a drag and drop. It's a 2-point problem here. And so both polygons appear to have blank number of perpendicular sides and blank number of parallel sides. Okay, perpendicular are form 90-degree angles like this. Okay, so let's look at our first one right here. And it says both, so they both have to have the same amount. All right, so if I'm looking for right angles, I see a right angle right here. And I also see a right angle right here. So I see 2. Let's see if I see the same thing here. I see one right here. And then I see another one right here. All right, so I also see 2. So I'm going to say 2 pairs of perpendicular sides. Now, parallel sides, what are those? Well, parallel sides are sides that don't touch. So I'm only seeing one right here, and I'm only seeing one pair right here as well. Okay, so I'm going to say that they each have one pair of parallel sides. And that is how we get 2 points on this problem. How did we do? Well, we had 38% of our students get 2 points, and so that's not extremely high. We had 39% of our students get 1 point. Now, we don't know which one was easier, which one was more difficult. Counting each of these perpendicular sides separately might have confused some of the students. They might have confused this and not sure that you can count that twice. So I'm thinking that might be it. But obviously, this is a huge vocabulary problem. And so we just need to spend time making sure we understand what the words mean, but then just counting how many pairs. And so let's look at like squares and rectangles, right? Do we recognize that if we see a rectangle here, how many pairs of perpendicular sides? Well, I've got 1, I've got 2, I've got 3, and I've got 4. If I'm looking at parallel sides, I've got 1 and I've got 2. We need to be able to count more than simply one at a time. And so that's going to give us some opportunities to work with students. If we put those together, get that half credit, we've got about 58% correct. And so that's good enough for 12th easiest, but really a lot of that is coming off the back of that 1 point half credit. And we're not sure which one was more easy for students to access than the other. For number 7, we are looking at two-step multiplication and division problems. This is 4.48. And we have workers at a school cafeteria. They had 53 pizzas for lunch. Okay, so each pizza was 58 slices. Okay, so I could literally draw 58 pizzas or 53 pizzas, and each of these was cut into 8 slices. So first off, I want to figure out how many slices do I have? Well, I've got 53 pizzas, 8 slices each. I'm going to multiply those two. So 53 times 8. Okay, so that's going to be 40, and then that's 42. So I've got 424 slices of pizza. Now, what can I do with those slices of pizza? Well, each serving was 3 slices. So now every kid gets 3 slices, which is a decent amount of slices. That's good. One slice is typically not enough. So I need to take that 424, and my question is how many servings of 3 can I get out of it? How many threes can I pull out of there? All right, well, that looks like we're going to divide. So, because I've got my total, and I've got the number in each part, I'm looking for the number of groups. So let's divide 3 into 424. And this is where we need to utilize our long division skills. All right, so look, I've got 4 slices. I can get that one last serving in there, and I've got one slice left over. So one slice left for me, I guess. And so what's the most I can create? I can only create 141 servings because each serving has to have 3 slices. So my answer here is going to be A. How did we do? Well, only 41% of our students got this. We had to multiply and then we had to divide. The numbers got fairly large. We had 23% of our students get 424, and you notice where this came from? The number of slices they only did step 1. And that's always a problem with these two-step problems is they'll stop at step 1, they'll see their number, they'll see 424, and they'll hit it and move on. And then we understand where this came from. This 22% chose this. They took the remainder one. They figured that there's a 142nd kid that could eat that. They just added that in there. And so that's the mistake on that one. And so this one was definitely on the more difficult side. This was actually the 5th hardest item on the test. And so these two-step problems, sometimes we represent them, sometimes we solve them, always going to be a challenge for students. Number 8, we are looking at lines of symmetry. This is 4.6b. And we need to find shapes that appear to have all of their lines of symmetry drawn correctly. And so let me move this up here. Okay, so this line of symmetry right here on this trapezoid is good, but this one is not, because if you flip this over, right, it's going to kind of look like this. So it's not this one. This triangle. Let me see, if I flip it, it's diagonal right here. Yeah, if you kind of rotate it, yeah, this side matches up perfectly with this side. Obviously, this vertical one is good. And then this diagonal, you know what, the diagonal also works. Yeah, this one is actually going to work. This is what we call an equilateral triangle. And on an equilateral triangle, all the diagonals also work. So I need one more. See, this is not an equilateral triangle. This is an isosceles triangle. So this works right here, this vertical. But this diagonal does not, because look how much bigger this side is than this side is. So they're not going to line up. Same with this diagonal. That's not going to work either. And then a square has diagonals that work, but not a rectangle, because look, if I'm looking at this side right here, is much longer than this side right here. So this line of symmetry doesn't work, neither does this. Neither of them work. Okay, that heart is pretty basic. There's just one line of symmetry. We nailed it. So it's that equilateral triangle and the heart. Now, those are our two answers. How did we do? Well, we had only 19% of our students get 2 points. Only 19%, but watch this. We had 72% of our students get 1 point, and I guarantee you that's the one they got. So this equilateral triangle probably stumped a majority of our students, but thankfully we get half credit for it. We had 0 points was 9% of our students, but if you put those together, we're actually not doing too poorly, right? So what we do is we take half of that 72 because that you get half credit. You take the 19 in case you want to see how it works. Just add that 36, and that's where that number comes from. So overall, we've got 19% of our students that get 2 points, but there's 55% of our students that got this correct if you want to give the half credit. So that ends up being not too bad. This is a little bit on the easier side than the harder side, but kind of middle of the road, 13th easiest item on the test. But it was this equilateral triangle that I think really stumped students. For number 9, we are looking at 4.9b, and we are solving data problems here. And so as we are looking at this stem and leaf plot, instead of simply representing it, that's 4.9a, we need to actually solve it. So we're looking for the total number of minutes for the 2 days that Brianna practiced the longest. Okay, total for the 2 longest. Well, we need to be able to read this. Here's our key. The 2 on the stem is going to be this 2 here. So this is going to be our tens place. And then the 7 is the leaf. That's our ones place. So pretty standard. What are the 2 longest? Well, each of these leaves represent a different number. So each of those numbers are going to be represented there. I've got a 70 and a 70. And so I'm just simply adding 70 and 70 because I need the 2 longest days. And there I go. I've got 140. So pretty simple. We can do that addition in our head. How did we do? Well, 59% of our students got this. So actually not that bad. We actually had our biggest distractor down there at D, 138. They might have got confused and think that 70 was not repeated twice. And so you can actually get there if you do 70 plus maybe you pick up the 68. You're not sure what to do with 70 if you can use it twice. And then so you get close, but you're just not quite there. And then we had 17% of our students get 52. And you can probably figure out how to get it. Look at it. They did the right thing in the wrong direction. They picked the 2 least values, right? They didn't translate this longest into the greatest. They translated that into the smallest, and they did 25, 27. So they knew how to read it. They just got tripped up on that word right there. And only 3% of our students got 15. So overall, this was tied for our 10th easiest. So it's more on recognizing how to use the stem and leaf plot, less on actual difficult calculations. For number 10, we are looking at equivalent fractions. This is 4.3c, and we need to find fractions equivalent to 4/6, 4.3c. In third grade, we really spend time on focusing using representations to generate equivalent fractions. In fourth grade, it's just the algorithm. Well, what can I do with 4/6? Well, you can, if they're both even, you can always divide by 2. So let's divide by 2. Now, when we divide top and bottom by 2, remember 2 over 2 is 1. So when you multiply or divide by 1, you're not changing the fraction, you're just making it look different. 4 divided by 2 is 2. 6 divided by 2 is 3. So I can get 2/3. That's as small as I'm going to be able to get. So what if I took my 4/6 and I doubled it? So let's just go simple. Let's just double it. So that's going to be 4 times 2 is 8. 6 times 2 is 12. And there we go. Those are 2 equivalent fractions that are available there. Obviously, there are an infinite number of equivalent fractions that you can keep multiplying by 3s, by 4s, by 5s, and whatnot. But typically, we're not going to get that big. So We actually had 60% of our students get 2 points, which is fantastic. Anytime you get to that 60% margin, you're feeling like the students were able to successfully complete that problem. And that's just the 2 point. We also had 27% of our students get 1 point, and we still had 13% of our students get 0 points. You get that half credit for 27, you're looking at 74% correct overall, which makes this the third easiest item on the test. So excellent job on working with equivalent fractions. That skill of generating equivalent fractions they will need the rest of their life. So it's extremely important in fourth grade. We lock that down. For number 11, we are looking at 4.5a. We are representing an unknown quantity. We have a letter here. In this case, we're looking at the letter C, and we need to represent this. Now let's see. Kenji makes 24 cupcakes. He eats 3, gives 12 to his friends. How much cupcakes does Kenji have left? Well, we need to recognize when they give you this simple declarative statement, Kenji makes 24 cupcakes. That's our total. We're not adding to them. Now we're taking them away. So I want my 24 to be my total. Now what am I doing with that 24? Well, I'm going to eat 3 of them. I'm going to give 12 away. And then there we go. C is how much I have left. Now, they've got their total on the bottom. That's fine. So it can either be this one or this one. And as you can see, it is going to be this D, this 12 CCC. It's not 3 C's. It's just he eats it's 3 of them. So our answer here is going to be D. And we had 47% of our students able to get this. 25% were able to get this. Now, probably, most likely, they were not able to recognize this as the sum. And a lot of times, when we're dealing with letter as an unknown quantity in fourth grade, that letter ends up being the total, right? And you end up solving for that. That's not always going to be the case. In this case, this unknown quantity is just a part, it's not the whole. So we can't always show our students problems where they're just trying to add up all the numbers and then the answer equals C, because that's obviously not the case here. C needs to be both the part and the whole, because in this case, it is the part. We had 19% of our students get this. They obviously recognize that 24 was the total. They just messed up on what to do with the 3 and the C. And then we had 9% of our students choose this. So this was actually on the harder side. This was tied for our ninth most difficult item. And so we need to provide extra opportunities for when students are dealing with representing with an unknown quantity, where that C or that unknown is both the part and the whole. It needs to be both. For number 12, we are looking at 4.2g. We are relating fractions and decimals. And this is a readiness standard, but typically our students will do fairly well. And so what we'll get is our problems will actually now not be simple proper fractions. We're dealing with whole numbers. We're dealing with improper fractions, because look at all of these are greater than 1. So gone are the days to where we're asking students, what does that equal as a decimal? Okay, we're not going to see that anymore. Now we're going to see these numbers that are larger than 1. Okay, so how can we convert each of these? Well, let's look at 3.40. All right, so I'm going to put this in a place value chart. So this is my ones and this is my tenths. All right, so I could put that 0 there, but since I know that that's a tenths, then that's not going to work. So what I'm going to do is I'm going to take this tenths here, and I'm just going to grab all of these numbers and put them over tenths. So you can call that 34 tenths. So they had this as 340 tenths. And it would be 340 hundredths if you added that 0. We're good right there, but that's not going to work. So let's look at this right here. 3.04. Right, so this is my ones, my tenths, my hundredths, And we're trying to convert this into hundredths. Okay, so let's take our hundredths. So here's our place value here. We're just going to grab all of these numbers. They call it 304 hundredths. So that looks good. Let's double check the other two. 304 tenths, or 304 hundredths into tenths. Ones, tenths, hundredths. And you see they want us to convert it into tenths, but that doesn't work because I've got a number sitting over here in the hundredths. So that's already just not going to work. And then let's look at this last one, 3.40. They do want me to convert into the hundredths, so we'll go ahead and do that. Ones, tenths, hundredths. So we're going into the hundredths place. So I'm going to grab my hundredths, and then all the numbers to the left of that. And it needs to be 340, not 34. So that doesn't work. So our answer here is B. But you see all that work we had to do? Our problems are much more difficult. We're not doing these anymore. So 47% of our students got this correct. And you see, we had 25% of our students choose D. Pretty close. They got the 34 and they see the 34, right? But they obviously just got the wrong denominator. That would be 34 tenths or 340 hundredths. And we had 14% get A, 13 get B. This is difficult for students now. And so we need to have them just practice this conversion here of these numbers that are larger than 1. How do we convert those into improper fractions and then vice versa? That's the challenge there for students. This was actually tied for a 9th most difficult item on the test. And so what used to be a fairly easy standard is now a more difficult standard. For number 13, we are comparing fractions. This is 4.3D. And we need to find a fraction that is less than. Now watch that. I bet you we're going to get some kids that miss that. We need a fraction that is less than the value of this. Well, what is this? 1, 2, 3, 4, 5, 6. Out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 6/12, which is really a half, right? Half of it is shaded in. I need a fraction that is less than 1/2. Well, I don't even necessarily need to find equivalent fractions and have the same denominator to do this because I can easily tell if a number is equal to, less than, or more than a half by the relationship between the numerator and the denominator. Half of 4 is 2, and 3 is greater than that. So 3/4 is greater than 1/2. It's not what I want. I want less than 1/2. 1/2 is equal to 1/2. I don't want that. Half of 10 is 5. 6 is greater than 5, so 6 is greater than 1/2. I don't want that. Half of 3 is 1/2. 1 is less than 1/2, so that's what I'm looking for. So our answer here is D. How did we do? Well, we had 44% of our students choose this. Now, what's interesting is we had 32% of our students choose C, which is clearly greater than 1/2. But that probably lets us know that we had a large misconception around how fractions work. Because you see we had 6 shaded, 1, 2, 3, 4, 5, 6. And on this 10 right here, this is 10 is less than 12. It's because they know that there were 12 total pieces. And so the thinking might have gone, well, if 10 is less than 12, then that means it's going to be less than 1/2. What we don't realize is that as your denominator gets smaller, each piece gets larger. And so 6 pieces out of 10 is larger than 6 pieces out of 12. And so there's just a little bit of miscommunication or misconception there for our students. And this was definitely on the harder side. This was actually tied for our 7th most difficult item on the test. It's a one in which our students need some additional practice. For number 14, we are looking at input-output tables. This is 4.5b. And as you can see, we've got some inline choice we're going to need to make there. We need to be able to find the relationship between the input and output numbers. We need to find the rule. Well, Our input and output are going left to right, so we need to be looking left to right. Our numbers are getting larger every time, so there are two ways we can get larger. We can add or we can multiply. So 5 plus something is going to get us 25, or 5 times something is going to equal 25. And if 5 times something doesn't equal that other number, then you can tell it's going to be addition. In this case, you could do it both ways. So we could do a plus 20, or we can do it times 5. Either one of these could work. That's why we tested. So let's do 10 plus 20 equals 30. Yes. And then 10 times 5 equals 50. That's not what we need. So I'm thinking it's plus 20. Let's just verify. 15 plus 20. Yes, 35. And 20 plus 20 equals 40. All right, so we are going to add 20. So let's get plus and then 20. And that is how we get our answer. This is a 2-point problem. And so we actually had 65% of our students get 2 points, which is great. We had 13% of our students get 1 point. We're not sure which one they got, which one they missed. 22% get 0. So if you take that half credit from 1 point, you're looking at 72% correct, which makes this fairly easy. In fact, this was the 4th easiest item on the test. So this was pretty good for our students, especially in the middle of the test. For number 15, we are looking at fractions and decimals on the number line. This is 4.3g. And we are simply trying to discover a point 0.4 or 4/10, right? We need to convert those two from 0. And first, let's make sure it looks like all of these are in the same tick marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, these are tenths. Sometimes you'll get some and they're not all tenths. So it looks like they're all tenths. So we're just counting tick marks now. 1/10, 2/10, 3, 4, 5. This is 6/10. This is 1, 2, 3/10. This is 1, 2, 3, 4/10. There's our answer. This is 1, 2, 3, 4, 5, 6, 7/10. All right, so our answer here is going to be C, and most of us got it. We had 75% of our students get this. Now, what's interesting is 20%, right? That only leaves 3 and 2 for A and D. 20% chose B. What's the misconception? It started with a 0. Because if I start at the 0, I've got 1, 2, 3, 4. I've got 4 different tick marks. But a full 20% of our students, 1 out of every 5, they started counting from 0. So that's just an easy fix for us when we're working with them. This was fairly easy. In fact, it was the second easiest item on the test. For number 16, we are looking at area and perimeter. This is 4.5D. Now, it seems like a pretty simple setup, but we've got to do a few things here. So we need to find this rectangle here. They give us the perimeter. T equals 80 feet. The length is 23. Okay, so let's just say this is going to be my length of 23. I'm looking for the area. Well, how do I find my area? Well, my area is length times width. So I know what my length is. I don't know what my width is, but I can figure that out if I use my knowledge of the perimeter. So the perimeter is going to be all 4 sides. So if my left side is 23, my right side is 23. Okay, so what are those two together? Well, that's going to be 46. So the two lengths equal 46. So how much does that give me left between these two? Well, that's going to be 34. Now, that doesn't mean that each of these are 34. That means I've got 34 that I need to split between these two, right? And so if I take half of 34, that's going to give me 17 and 17. And if you're not sure, let's just check. 23 plus 17 is 40. So there's another 40. So they go back to 80. Now I know my length and my width. My length is 23. They gave it to me. My width is 17. Now I need to multiply those two. You see how much work this is? 23 times 17. So that's going to be 21. That's 14. That's 16. And I'm just going to write my 23 down. And that's going to be 391. So this is our correct answer here. And only 34% of our students were able to get this one. More students actually chose B, 103. Now, how did we get this? You'll laugh when you see how we get 103. You just take your 80 and your 23. Now, that has nothing to do with area. You do not add to find the area, but for some reason our students did not have a toehold on this problem. And when in doubt, you take your numbers and add, and you figure that's it. And that's obviously not it, but this is probably conceptually beyond some of our students. Step one is always to draw a picture and realize that I'm looking for the length and the width, and I can use my perimeter to find my width. There's a lot of steps here, but more students chose the easy way out because they didn't feel like they had a plan of attack on this one. And so this was definitely difficult. This was actually tied for our first hardest or our most difficult on the entire test. So this was definitely a challenge. For number 17, we are looking at expanded notation. This is 4.2b. We have an expanded notation version. We need to put it into standard form, and there's no A, B, C, or D. We're just typing in our answer here. So it looks like our largest place value is in the thousands, our lowest place value is in the hundredths. So let's go ahead and build that. What I want to do is I want to build my place value chart here. Let's go ahead and just build it using the place values. So 1,000, 100, 10, 1, the big decimal right there. So tenths, and it looks like we're doing decimal form, and then hundredths. Let's make that tenths. There we go. All right, so that's going to work for us. And now, look, if we do it like that, if that's our place value chart, we're literally just matching. 9 goes in the thousands place. 5 goes in the hundreds place. 7 goes in the ones place. There is no tens. I've got a 4 in the tenths, and I've got a 1 in the hundreds. Now, if we don't put anything there, it's going to look like 957. It's not what it is. It's 9,507. So that's going to be our answer, and we just need to type it in like that. So let's type this in, 9507.41. All right, that is our answer. Now, how did we do? Well, this was the 16th hardest. So kind of right in the middle of the test. Probably we would have done better if this were A, B, C, or D, but it's always a little bit more rigorous when we add the equation editor. We just have to type in the answer. We can't double check. We had the 1 point problem, 51% of our students get it correct, 49% did not. So right in the middle of the road. This one is a challenge, more so because of the equation editor than others. So when we are working with our students, let's just have them take this straight into standard form and not select from A, B, C, or D. Sometimes the test prep we do with our students does not help them because they can rely on having 4 pre-chosen answers for them. They should go straight into writing it on their own. That will most mimic what we see here on the equation editor. For number 18, we are looking at adding and subtracting whole numbers and decimals. And so this is going to be Dylan with 7 ounces of sugar in 1 batch of cookies. We've got 5.3 ounces of sugar in pie. How much more? So this is a comparison. And so since we are comparing these two, we need to kind of do it like this. Think about it like this. We've got 7 ounces of sugar in the cookies, and we've got 5.3. 5.3 is less than 7. That's in the pie. And we are looking for this gap right here. What's that gap? Now, the challenge here is that if you line it up like 7 minus 5.3, you notice how that's all wacky, right? That's not going to work. So we need to line up the decimals. That's what our teacher always tells us, but there's no decimal in 7. So we need to know that when there's not a decimal, you can always place a decimal after the ones place. So we could do it like this. This is how we properly line this up. And then at this point, we would go ahead and put that 0 in the tenths place up top. So now we could treat it like 70 tenths minus 53 tenths, right? We can just kind of ignore that decimal once we bring it down. And that's going to be regular subtraction after that. So we have 1.7, 1 and 7 tenths. So our answer here is B. Now, we had 54% of our students get this correct. So just slightly better than the last one. We had 18% of our students get A, 16, and 11 respectively for C and D. Now, how did we get 2.3? Well, watch. If I knew how to line it up, and I'm not sure what to do, I could just take, well, 3 minus 0 is 3. You see how I kind of thought of that backwards? And then I do that too. That's where that's coming from right there. 12.3, you probably can tell it's 7 plus 5.3. So we just missed the how much more signal for comparison. But overall, this was 14th easiest, so kind of in the middle of the row, but slightly on the easier side of the test. For number 19, we are looking at the base 10 number system. This is 4.2a, and we have defined a true statement. And so we're dealing with tenths and hundred. We're dealing with all kinds. Okay, so let's do this. Let's build a place value chart. And since there's multiple options, I'm just going to put my numbers up top here. 10. Doesn't look like I go to the hundredths. I'm just going to go to 1, and then since I've got the space, I'll go ahead and put the hundredths right there. All right, so 300, so let's build 300, is 1/10 the value of 30. Actually, no, 300 is 10 times 30 because it's moving one to the left. If it was 1/10, then it would be 3,000. So 300 is 1/10 the value of 3,000, going in the wrong direction. So that is going to be incorrect. 1/10 means it's smaller than 300 is actually 10 times bigger than 30. All right, let's look at this next one. Just going to change colors there. 3 hundredths, there's my hundredths. 0.03 is 1/10 the value of 3 tenths. Okay, yeah. So if you're 1/10, that means you're 10 times smaller. And 3 hundredths is definitely smaller than that 3 tenths. And since they're both 3 and they're one decimal place over uh, to the left of each other, then yeah, that looks like that's going to be good. Let's verify that these other two don't work. And let's extend our lines down here so we can keep going. We can use this place value chart to kind of keep ourselves organized. So 30 is 1/10 the value of 3. No, 30 is 10 times 3 because 30 is bigger because 3 times 10 makes 30. So 30 is 1/10 the value. If we wanted to, we could say 30 is 1/10 the value of 300 because it's 10 times smaller. And then finally, let's check this final one. Should be wrong as well. 3 is 1/10 the value of, no, it's not 1/10, it's 10 times. We could say 3 is 1/10 the value of 30 if we wanted to put it like there. But no, 1/10 means 10 times smaller is what that means. And so you have to say 3 is not smaller than 0.3 or 3/10. 3 is larger. So our answer here is B. How did we do? Well, this is a supporting standard that sometimes does not see enough time. This is only 44% of our students that got this correct. And look at our answer selections here. We had 25% chose D, 18%, 14%. And so we know that 1/10 goes with 3 and 3/10. The problem is they need to be flipped. So I would suggest using a place value chart here to kind of keep that in mind. And just think 1/10 equals 10 times smaller. And keeping that word smaller in there might help our students visualize, oh, 30 is not smaller than 3, or 300 is not smaller than 30, or 3 is not smaller than 0.3. It's not just smaller, it's 10 times smaller, but even that word smaller might help us. This was hard. This was actually tied for our 7th most difficult item on the test. And so it needs a little bit of extra love as we are looking at this year. Number 20, we are converting units. This is 4.8b. And we have a table here, and it shows the difference between feet and the difference in miles. And we're trying to convert 7 miles into feet, is what that looks like. Well, if you look at your formula chart, guess what you're not going to find? You're not going to find how many feet are in 1 mile. You're going to see how many feet are in a yard and how many yards are in a mile, but you don't have a straight miles to feet. So the table can help us do that, right? Or we can use what we have on the formula chart. Both work. So let's use the table. If 2 miles are 10,560, then I could divide that by 2. Now, this is a pretty long division. This is larger than anything that we really do in 4th grade, but the same algorithm works all the way across. So let's go ahead and do long division. That's going to be 5. Remember, we're just going to do one at a time here. It's going to be 2. It's going to be 8. Still need that 0. 5,280. We can also think it's feet in 1 mile. Or we can say 1 mile equals 1,760 yards. That was on the formula chart. Each yard equals 3 feet. So we can multiply 18, 21, 22, 5,280 feet in 1 mile. Either one of these works. That gives you the 1 mile conversion rate of feet to miles. Now we need 7. Okay. So we can say, let's multiply this by 7. 0, 56, 14, 19, 35, 36. 36,960. Our answer is D. As you could tell, that was quite a few steps. We could also just use a little bit of reasonableness here to try to figure out, right? So 6 is going to be just a little bit past, or 7 is going to be a little bit past 6. And so you notice that we're going up by almost 10,000 when we're going up by 2, right? We're going plus 2, plus 2. So I'm thinking this is going to be a plus 5. Because 5 is half of 10, and that would give me a 36,680 as a rough estimate. And you see how that's the only one that's close. I might have a difficulty choosing between B and C, but B and D, but A and C are much too large. Either way, how did we do on this? Well, we only had 34% of our students get this one correct. Now, 30% chose this 42. And what that 42 is this is 8. This is 8 miles. So they just took this pattern, they found the difference, and then they just added that 10,000 or almost 11,000. And then they just put that up there. And so that really didn't help them because we had almost as many students choose B as D. And then 63 is the next closest. Not sure how they're getting that. Other than look what you can do to get 63. You can actually get there, but I'm not sure why students would do this because it doesn't really make much sense. You can take all 3 numbers and you can add. When in doubt, take all the numbers and add, right? Well, that's going to be an option. And then we've got A, which is just 10%. So just kind of another throwaway item. This one was extremely hard. So hard, in fact, it was tied for the first most difficult. Now, this really kind of gets close to what we talk about in sixth grade, which is unit rate. And so before students tackle this, they really need to think they have to find the rate of how many feet in 1 mile. If they can visualize or verbalize that, then they will know that they can just multiply that by 7 to get the answer. But they need practice thinking in the terms of unit rate, something that they do in middle school, because that's going to help them at least identify I need to do some type of division, figure out what my first unit rate is. And so it's understanding how to solve this and attack this is going to be uh, probably the first step. For number 21, we are looking at relative sizes, and this is just a recognition, a pattern recognition, not really calculating. We're just trying to find the weight of a basketball. And we simply just need to know the relative weight of things, right? So tons are used to weigh elephants and cars, so that's not going to work. And if we're not really sure about kilograms, right, we might think, well, that's 1,000 grams is in a kilogram. So this is really 22,000 grams. Think of those gram stackers. That's a lot. So now we're kind of stuck with ounces and pounds. Okay. Now, a pound, think about 1 pound, and I'll use LB to represent pound, is about a loaf of bread. So that's not enough by itself, but imagine a basketball weighing 22 loaves of bread. That's quite a bit. Now, what is these ounces? Let's see if we've got our ounces here. So we've got weight, we've got 1 pound equals 16 ounces right here. So that means this equals 1 pound, that's 16, and then I've got 6 ounces. So a little bit more than like a, a loaf and a half of bread. And that's actually what makes the most sense here. So that's our answer is C. That's what a basketball filled up, because it is air on the inside, is going to make up. And only 47% of our students were able to get this. 30% chose pounds, which at least they're thinking the right unit. There's just too many of them. We had 19 choose the kilograms, and actually 4% choose the tons, which is not very helpful. This was difficult. This was the ninth hardest, and really the easiest way to do it is to just give students a benchmark. All right, so what is a ton? What is a kilogram? I said a loaf of bread is a pound. What do we think about an ounce, like a paper clip? So we need to give them some relative benchmarks that they can use, and then use that to visualize how many of those would take to make a basketball or whatever it is we're trying to weigh. This was tied for our ninth hardest, so this was definitely on the harder side. For number 22, we are comparing fractions, and so this is 4.3d, and we need to find a fraction that is greater than 5/4. All right, so we need to look at all of these, and we can go ahead and get rid of b. Look, that's equal to 1. This is greater than 1. Let's get rid of c. Look, 5/10 is a proper fraction. 5/4 is an improper fraction. That means it's greater than 1. Right? It's equal to 1 and 1/4. I'm going to get rid of that. So I can get rid of b and c without doing any calculation. So let's look at a, and then let's look at d. And when we do that, we need to find common denominators. So I can change my fourth into twelfths. So I'm going to change 5/4. I'm going to multiply by 3s to get that up into twelfths. So I've got 13/12 and 15/12. Well, 13/12 is less than 15/12, but I want something greater than my 15/12 or 5/4. So let's do 4/3. Let's do twelfths, because I've already got my 5/4 into twelfths. That's 15/12. Let's multiply this by fourths, because 3 times 4 is going to get me 12. That's what I'm looking for. I need a common denominator. Look at that. 16/12 is greater than 15/12 barely, but it's going to work. And so our answer here is D. Now, we had 54% of our students get this. A big chunk of students chose A. Now, why did they think this? Well, if you think about it, right, 13 is bigger than 5, so the numerators are bigger. 12 is bigger than 4, but 13/12 is actually less than 5/4. So you can't just use that type of logic, and I think some students did. They just compared the numerator and denominator, and that did not help them. And so ultimately, this was right in the middle of the test, slightly on the easier side. This was the 14th easiest item on the test. For number 23, we are representing an unknown quantity, which is 4.5a. And we've got this little word problem here. We got 187 people on a trip, 152. So look, here's your total. And our students need to be able to recognize totals when they're given to us in problem situations. There are 187 people, boom, total. So I'm going to draw this right here. And then we're basically going to put it in chunks. We're going to put 152 students. That's a lot of students. I've got 11 teachers, and then the rest are parents. P stands for parents. So there we go. The students, the teachers, and the parents all together equal the total number of people on the trip. And so which ones are going to be correct? Well, you see this P is not the number of parents. That'd be a lot of parents, so that's not going to work here. And I can say if I'm looking for P, how could I find it? Well, I could find it right here. You see, this one works right here. Let's go and scroll down and make sure I'm not missing one. Yeah, that doesn't even include the 187. So it's not that final one, so I need to choose one of these. If I want to find P, well, this one I'm actually solving for P here, right? So this would be 187 equals 152 plus 11 plus P. That's what I did right here. What if I wanted to solve for P? How could I do that? Well, I would take my P, and what that is that's all the people minus the 152 students minus the 11 teachers. Whatever's left over after I subtract those two groups, the students and the teachers, that's going to give me my P. And so that is going to give me option 2 and option 4. Now, we actually did pretty well on this. We had 45% of our students get 2 points, which isn't that great. But for 1 point, we had 39% of our students get that. And so that gives you about 65% correct if you give that half credit there. And I'm guessing we probably got this one. It was this one. And so this is different than the previous 4.5a, where you weren't necessarily solving for the unknown. It was just a part, it looked more like this. So we need to have students be able to, from this strip diagram, we start with the strip diagram, be able to just basically write an equation that mirrors the strip diagram, where you've got the total on one side, and then you've got the parts on the other side. And then also write another equation where you're trying to find that unknown. And so you have to take the total and then subtract the parts. If they can get both of these equations out of this strip diagram, then students are ready for anything that they might see on 4.5a. And so this was on the easier side because it was a 2-point problem. This was actually tied for our 7th easiest item on the test. Number 24, we are looking at 4.9a. And so we are representing data here. And we just simply need to take the frequency table and make it match this data set here. All right, so let's just see. And honestly, we've got instead of just 1, 2, 3, 4, we've got the beginnings of what this will turn into in 5th grade. This will be a histogram, where it's like a bar graph, but you have ranges. So this is turning into a 5th grade histogram here. So let's just see. I've got 1, 2, 3. You see how this is already wrong? I've got 3 in the 1 to 4 section, and I only need 2, so I'm going to just stop. I've got 2 in the 1 to 4 section. That's fine. 5 to 8, I've got 1, 2, 3, 4, 5. And we're done because I should have 6. So that's what we're doing here. I've got 2 right here. Good. 5 to 8 should be 6. 1, 2, 3, 4, 5. And we're done. So it's got to be this bottom one. I've got 2 right here. 1, 2, 3, 4, 5, 6. Okay. And I need 1, 2, 3, 4, 5 in the 9 to 12. And then I've got my 1 right there. So that's the only one that matches D. And that's one way that we could use to solve it. How did we do? Well, 48% of our students got this correct. 19 chose A. And so there's an interesting way that students probably chose A. It might have been partly random, but look, if I'm looking at it like this, if I see a 1 and a 4, I see a 1 and a 4. And then what number should be in there? There's my 2. Then I've got a 5 and an 8. And what number should be in there? 6. Now that breaks down because 5 doesn't go between 9 and 12, but look, 9 and 12, 13 and 16. 9 and 12, 13 and 16. It's interesting how they come up with these distractors. But this is probably something that students don't have much experience with. We will turn frequency tables into bar graphs, into stem and leaf plots, but maybe not just raw data, especially with these. We need to have students have these experiences where they're not just using a frequency table with a particular number, but with a range. And we need to have these data ranges experiences for our students. Because that was actually raised what would typically be a pretty simple standard into a more challenging standard. In fact, this rated as one of the harder questions, tied for the 12th hardest on the test. Next, we are looking at 4.3F. So this is number 25, 4.3F, estimating fractional sums and differences. And so this one is definitely a challenge because look, we've got making some cookies. And so we can kind of do this right here. There's some cookies. I don't know the total. The total is unknown. So he's going to give 3/12. Let's just do it like this. 3/12 to his neighbor, 5/12 to his friend. What is true about the fractional cookies he has left. All right. So if we, instead of, since we're dealing with fractions, we can actually just go and write this as one whole, like one batch of cookies. So now our unknown is right there. So a batch of cookies, regardless of the number of cookies, it doesn't matter how many cookies there are. A single batch of cookies, which will include an unknown number. 3/12 go to the neighbor, 5/12 go to the friends. How much does Shan have left? That's our question mark. Well, this right here, since they're both 12ths, that's 8/12. 8/12 plus what makes one whole? That's 4/12. All right, so Shan has 4/12 left. But now we need to put this between these two. Okay, what is 4/12 going to be? Well, between 1/4 and 1/2. Okay, so let's go ahead and let's simplify 4/12. We can divide by 4s. It's going to get us 1/3. So let's look at 1/3 here. Okay, so could we say that 1/3 is between 1/4 and 1/2? So here's my 1/4, and 1/2. Could we say that 1/3 is there? Well, if I break this up into thirds, it is going to be right there. So that's actually looking pretty good. Could we say that it is more than 3/4? Well, my 3/4 is right here. Definitely not more than 3/4. Between 1/2 and 3/4, no, it's right here. So it's not here. And less than 1/4. No, it's slightly more than 1/4. Now, if we want to, what we could do is, that's just kind of a visual. If we really want to do this, to verify, we could do all this extra work and we can actually change these into common denominators. So let's change all of these into 12ths. So 1/2, 1/3, 1/4. So that's going to be sixths. That's going to be 4. And I just know that 2, 3, and 4 all make 12. And then if we look at this, that's 6/12ths, that's 4/12ths, and that's 3/12ths. And that 4/12ths is sitting right in between. Obviously, we knew that was 4/12ths because we already had that there. So that is going to be our answer. But we could have estimated there to kind of find the difference. This was definitely difficult. Only 34% of our students got this correct. 23 chose B, 30 chose C, and then 13 chose here. So honestly, stuck between these two right here. And probably if we're getting this right here, this is greater than 1/2. We know that 1/3 is less than 1/2. The one challenge is it less than 1/4 or is it between 1/4 and 1/2? But the biggest challenge is, do they even get 1/3? First off, we have to add the 8/12ths, the 3/12ths and the 5/12ths to get 8/12ths. Then we have to subtract that from one whole to get 4/12ths. Then we have to simplify that to 1/3, and now I can deal with that. Because now this 1/3 looks a lot like all of these fractions are throwing at me. 4/12ths doesn't look like any of those fractions they're throwing at me. So there's a lot of work we need to do before we even begin this. This was challenging. This was the other problem that was tied for the most difficult on the test. So this is one in which honestly it's all of this that's probably hard. And if they can even get this down to 1/3, then they still have all this work left to. I used a number line. You can actually change into common denominators if you want to. Now we need number sense, right, to be able to put these fractions in order, and that just makes it difficult. For number 26, we are looking at area and perimeter. This is 4.5b, and it asks us about a rectangle, and there is no rectangle. So our first thought should be, let's go ahead and draw something. So let's draw a rectangle, and it is going to give us a width of 6 and an area. All right, so they give us the area of 102 square units. And we need to find the length and the perimeter. Okay, well, what do we know about the area? Area equals length times width, and then the perimeter is double the length plus double the width. Well, I've got the width. The width is 6. I don't know what the area is, but don't know what the length is, but I do know what the area is. My area is 102, so I can say 102 equals length times my width of 6. So 6 times what makes 102? I can also write this as a fact family and think, well, 102 divided by 6 is going to equal my length, because that would be a related fact. So let's divide that 102 by 6. And that's going to be 4. It's going to be nice and even. No leftovers, no remainders. We've got 42. All right, so 17. Looks like this is going to be our length. Just to verify, let's go back. There you go, there's our 102. All right, so our length is 17. Now, we could use that to find our perimeter. Remember, perimeter is all the way around. So that means I need to double the length and double the width. Sometimes I like to do it like this. I like to take my length and width, 23, and then I simply double that. So that's going to equal 46. A lot of different ways to calculate the perimeter as long as you add all 4 sides together. So we're going to get 46. And so that is how we get our 2 points on this particular 2-point problem. And only 35% of our students were able to get 2 points on this one. So that was a little bit more challenging. We had 27% get 1 point, and then 38% get 0 points. So once again, if you take half of this is 14, add that, you're going to get about 49%. And so this was definitely on the harder side, kind of middle of the road, but leaning a little bit harder. This is a 14th most difficult item on the test. 38% students got nothing on this. So let's think. What do we need to know about this? Well, we need to know the difference between area and perimeter. They need to be taught together. So let's teach these together rather than separately because you can use information from one calculation to find the information needed to complete the other calculation. So let's teach these together. We need to know the difference between area and perimeter. One's units on the inside, one is the distance around the outside. And then we also need to give them the perimeter and the length and have them find the width, or the area and the length and have them find the width. So give them the whole and then the part and have them find the other part. Sometimes we always just say, well, here's your length and then here's your width. Now let's find area, let's find perimeter. That's a pretty straightforward calculation. What if we give them the length and then the area? Now I've got to think using inverse operations. I'm going to divide to find what that missing length is. That's the more challenging, and that's what our instruction needs to look like. For number 27, we are looking at adding and subtracting fractions. This is 4.3e, and we're looking at the shaded portion of the model, and we need to find an expression, right? So let's see, I got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. All right, so I should be thinking of 30th because there's 30 total, so that works. And so I'm thinking that's not going to work unless they simplify, but it's not going to be 5/5, 6/4, 5/5, right? Those are all over 1. That's not going to work. And then I'm looking at 1, 2, 3, 4. That's got 5 sections. 1, 2, 3, 4, 5, 6 sections. 1, 2, 3, 4, 5. Right, so one way would just be 5/30ths, 6/30ths, 5/30ths. And so that's going to be it right there. If we didn't see that, we can just add these up and say, you know what, it's going to equal 16/30ths. So we just need to find anything that equals 16/30ths. And so our answer here is going to be C. 63% of our students were able to get this. Now, what's interesting is we had 14% choose A, 14% choose D, and there's some interesting ways to get there, right? So we see this D right here. This is the shaded, and then we've added in the unshaded. So they made the whole, and we're not looking for the whole. We're looking for the fraction of the classroom that are used by teachers, and then the shaded part of the model represents the fraction that are used by teachers. So you've got to do this reading. Look, am I looking for shaded, unshaded, or both? Now, if you break this into columns right here, you can almost get, because it does kind of vertically separate itself. Look what we have on this A right here. I've got 5 shaded and then 5 unshaded right here. Next, I've got 1, 2, 3, 4, 5, 6 shaded and 4 unshaded, and then I've got another 5 and 5. So the students choosing A were doing something. They just really weren't thinking about how fractions work, and this is one whole, and we needed to find 30 as our denominator. So that gives us a little bit of clue into that misconception. They just need a lot more experience with fractions, but not fractions where all the shaded parts are together. What if the shaded fractions or the shaded pieces are in chunks like this, and we need to add them together? That's an experience that we can use to help them visualize adding and subtracting fractions. Overall, this was definitely 63% was pretty easy. This was on the easier side. This was the ninth easiest item on the test. For number 28, we are looking at fixed and variable expenses. So we've got our personal financial literacy here, and this is going to be 4.10a. And as you can see, we've got drop downs here that we're going to have to look at. And so we're looking at variable expenses, and that's it. It only said variable expenses. So what's the difference between a fixed and a variable expense? And this is our key word right here. Variable means it changes. And then what we do is we contrast that with fixed. So if it's fixed, it stays the same. And that's just that key word that we need to know. Variable means changes. Variable expenses are useful in personal financial literacy. We also use this word variable when we're talking about letters that stand for unknown quantities because they can change. So what changes? Well, look at these groceries. That's variable because it changes 212, 305, 275. This is going to be fixed. Let's put black around this because look, 39, 39, 39. We'll put an F right there. Housing, your rent or your mortgage payment, fixed. 835, 835, 835. But going to see the movies depends on whether you go out and whether there's a good movie or not. Those are variable. So the variable expenses are going to be, what did we say? We said the groceries and the movies. Now, because the amounts changed each month, these three are going to work. Now, here's the thing. I can't say movies are movies, and I can't say groceries are groceries. But I can say movies and groceries, or I can flop these and say groceries and movies. These work in either order. As long as you get both of those in either order and you just don't repeat, you're not going to do movies, movies, or you're not going to do groceries, groceries, then you're good. You actually get your full credit here. So we had a 1 point problem. So even though there's three different drop downs, there's only one correct statement here. You need to have a combination of movies and groceries and changed. If not, the statement is incorrect. So this was either all right or all wrong. And we had 48% of our students get it correct. So not horrible, but definitely not on the easy side. It's actually tied for the 12th most difficult item on the test. This is just one of these personal financial literacy items that we just need to teach. We need to make sure they have a little bit of experience. We need to review it before the test because that variable and fixed, those are just those words that are very important. For 29, we are looking at modeling division. This is 4.4e. And in this case, we are modeling division with equations. Sometimes we do it with strip diagrams or arrays. So we've got 720 gallons of ice cream. There are an equal number of gallons of each type. So this means we're going to either multiply or divide. We've got chocolate, strawberry, mint, and vanilla. Okay, so we got four types. So 720 gallons. Just draw a strip diagram. I've got four types and they're each equal. And I can just cut it into fourths. And here's my question. How much is in each type? Well, what are some different operations I could get from this strip diagram? Well, I can easily do 720 divided by 4 equals 180. And I guess that's the correct answer. They wouldn't give us incorrect numbers there. So this could work, which means I don't want it because I'm looking for the one that cannot work. 180 divided by 4 gets me 45. That doesn't look like that's the same. Look, 4 times 180 equals 720. This is the inverse of this right here. These two go together. And then this 720 divided by this is a fact family, right? It just flips those two numbers, the divisor and the quotient, and that's fine. And so you see the one that sticks out is B. And so that is the one that doesn't work because that can't help me figure out how many gallons each of the type of ice cream they have. And it has different numbers, but only 42% of our students were able to see this. We had 21 up here, we had 22 down here, we had 16. And so this is pretty much evenly spread out, which means they either knew it or we were just guessing. This cannot might have messed some students up. They might have seen this first one. Whenever you see a cannot, the first one is probably going to work. And students that don't read will get stuck on A, so that probably trips some people up. C might have tripped some people up because it's the only one that's multiplication, and they're thinking, oh my goodness, you can't multiply. This is a division problem. Divide, divide, divide. So they chose the one that is multiplication. But if you think about it, you can think blank times, or actually it would be 4 times that blank equals 720. And that's really what that is. They just inserted that 180 in there. But yeah, you could do 4 times what equals that 720. We need to see that relationship between multiplication and division. So we don't get tripped up on things like that. And so this is actually on the harder side. This is the 6th hardest item on the test. I would suggest starting with a strip diagram and then thinking about from the strip diagram, can you pull 4 different equations from here? You should be able to get 2 multiplication, 2 division from this strip diagram. Think of fact families, and that's students should be familiar with that. And if we can do that, then these particular problems are going to be super easy. For number 30, we are looking at relating fractions and decimals. So we see a drag and drop here. This is 4.2g. Now, 4.2g, long gone are the days where we're just looking at proper fractions. We are looking at improper fractions or mixed numbers, most likely here. And so we need to find ways that we can make 84.9 or 84 and 9 tenths. Now, there are actually 3 different correct answer options from this. So I will show you what they are. So the most traditional way is going to be this. We just do 84, and then we're going to do 9 tenths. This works. And we don't know how many students chose this, but if you did this, you're good. 84 and 9 tenths. Now, if you wanted to, you can actually do this, 84 and 90 hundredths. Because those extra zeros don't do anything, 90 hundredths is the same as 9 tenths, right? You just take off these extra zeros and you're good to go. But there's a third one here. It doesn't even, you don't even have to use that number right there. You could do, and get all those out, 849. Get that 90 out of here. If I think of 849, lump that together, what's the place that that last digit is in? It's in the tenths place. So if you were to do 849 tenths and then leave that one, right? It is going to give you a warning symbol. It is going to say that, are you sure you want to leave? But if you were to actually say, yes, I want to leave, it would still mark that as correct. Now, most students won't. I would feel really nervous doing that. But if you look on the answer key provided by the state, they will actually say that is a correct answer because it is technically correct. 849 tenths. This was a 1-point problem. You either got a correct representation or you didn't. And so we had 50% of our students get it right, and 49% get it wrong. We had some few students just leave it blank, obviously, to get that missing 1%. So this was right in the middle, 15th hardest item on the test. When we're working with 4.2G, we've got to get away from proper fractions less than 1. We've got to think of mixed numbers. We got to think of decimals, and because that's just the reality of what our students need to be able to do. We're not doing convert 9 tenths into 0.9. That's the basis of it, but it's got to be a number greater than 1 or it's got to be an improper fraction in order to challenge our students. So I'm going to move forward. It is going to ask me if I want to move on, and I will say yes, because I know it's right. For number 31, we are looking at larger multiplication, and this is 4.4D. And it's a very simple setup here, so as long as we recognize it, it shouldn't be that difficult. We've got $7 for each ticket. We have 2,158 tickets, so each lets me know equal group. And I am looking, I've got 2 parts, 2158 and 7. I'm looking for the total, which means I need to multiply. So it's just 2158 times 7. So if you see that, this is just the basic what we do in 4.4D. We go up to 3 by 2, or we go up to 2 by 2, or to 4 by 1. 3 by 2 is what they do in 5th grade. So we need to practice this 4 by 1 as much as we do the 2 by 2. And so that's 56, that's 35, that's 40, that's 7, that's 11, and that's 14, that's 15. So there we go. We got 15,106. We were able to get 59% of our students to get this correct. So that's pretty good. And then if you look at the other answer choices, not one of them really stood out. So those are just incorrect ways to multiply. This is actually division, so that's kind of scary. But these are just we forget to carry something, you put an extra zero somewhere, things like that. That's how we get these detractors. This was definitely on the easier side. 10th easiest item, or tied for the 10th easiest item on the test. And this is just work on that algorithm, give them tons of practice. If they'd rather do partial products, right, that could also work as long as we're thinking of it correctly, right? That's going to be 56. That's going to be a 0 and 35, 350. That's going to be 2 zeros and 700. That's going to be 3 zeros and then 14. Now, as long as we add everything in nice, neat rows, right, we're still going to get the same answer. So partial products works as well if that's better for students. For number 32, we are measuring problems. We're working with measurement problems. This is 4.8C. And so we've got inline choice that we need to come up with here. We've got a distance of 3 days. We've got 8:62, 12:35, 9:23. How far does Kira walk during these 3 days in kilometers and meters? So they give us everything in meters. So first, let's just add it up. 8:62, 12:35, 9:23. So that's going to be 7:10. That's 10:12. That's 10:20. All right, so 30:20. Now, there is no 30:20. I need to change this into kilometers and meters. Now, if I'm stuck, I can go to my reference materials, and I know that there are 1,000 meters in a kilometer. So I need to take sets of thousands away from here. So one way to do it, to visualize it, would be to think of repeated subtraction, right? Rather than division. You could also do division, but I don't really want to divide with 1,000 as my divisor. So if I take out 1,000 of these, now I've got 2020, and this is kilometer. I'm going to take out 1,000 here, rename it as a kilometer. I'm left with 1,020. Take out my final 1,000, rename that as a kilometer, and I'm left with 20. So how many kilometers I have? Well, I've got 3 kilometers, and I had 20 meters left over. So this is once again a 1-point problem, even though there's 2 drop downs. You either get it right or you don't. And so this is definitely a little bit more challenging. We only had 35% of our students get this right. And we had 65% basically get that incorrect. This was the 4th hardest item on the test. I'm hoping the difficulty was not necessarily in adding that. All right, look at our answers here. We couldn't have put that 3020 there in either way. Now, what we could have done is, we could have uh, just put the 3000. Like there's different ways that we could have kind of gotten around it, but we couldn't have just been stuck on step 1 and then entered this as an answer, because 3020 was not one of the options. But we have to take these units and then convert them. And so this is just one method of subtracting sets of 1,000. There are different ways you can visualize it. You can divide it, and then your remainder is going to be the amount in the meters, but then you're dividing with, like I said, a divisor of 1,000, and that's going to be a bit much.